So we started off this season. Our team numbers 919A were Reverb Robotics, and it's our table of contents on our engineering notebook. So we started off this season strategizing about the challenge. Here are all of our policies and stuff. Let me skip through that. So this is a competition reveal day meeting that we did, and we met at one of our team members' houses, and we came up with different designs that would be possible for this year's challenge. And we came up with like launcher mechanisms. This is a piston mechanism, a catapult piston mechanism, and this is a flywheel at high speed. And we came up with a passive claw for the caps, and we came up with a motorized claw. And we figured out that the passive claw would be better because it would be it wouldn't require us to use a motor, and it would still complete the task efficiently. And we realized that the balls are not made of foam. This is incorrect. They're made of plastic, so they're easier to control. And the disc is about 0.75 pounds, so it's not very heavy, and it's made of plastic. And they're neutral objects. All the game objects are neutral, so it's different from last year's competition in that way. And our first design, we came up with a flywheel mechanism that's on a lift, either a elevator lift or a double reverse 4-bar, and it picks up the cap by having it inserted into the small crevice that you can see here, and it picks it up with maybe grip mat or something that allows it to stay on. And we also realized that a disc flipper would efficiently score us points during the competition, so we just came up with a small schematic for what the disc flipper would do. And a possible implementation we came up with was a planetary gearbox that just spins it at a high speed and with maybe tension. And then we did a game evaluation, and we sketched out the field, and we came up with the objectives of the game and some game restrictions. And while doing this, we figured out that your robot is not allowed to expand unless it's in the expansion zone, which is behind this. So our previous, the first design we came up with wouldn't work out because it required the launcher to be on the lift, which is not allowed. So here's the design brief that we didn't do yet. And here are some cost-benefit analysis charts we did for the chassis to figure out what design would work out the best for this challenge. And so, as you can see here is the chassis structure. We figured out a hex drive might work out because it allows us to have easy maneuverability on the field, but we figured out that a tank drive would be better for climbing onto the platform, and it would work out better with traction wheels. So here's a cost-benefit analysis chart of traction wheels versus Omni wheels, and we figured out traction wheels would allow us to get onto the platform better. Here's some charts. And then here's the gear ratio. We did neutral, which is 200 RPM, high torque, which is 100 RPM, and high speed, which is 600 RPM. And we did a cost-benefit chart for all of them. Okay. And then I sketched out a final design of what our chassis might look like at the end, while we're in the building phase or CADing phase. And I did a side view, front view, orthographic view. And then here's today's meeting where we figured out new possible designs that would work out for this competition. So here's all of that. Here's a double reverse 4-bar, which might not work out as well with one motor because we only have one motor that we're allowed to use on the lift if we want to keep up with our motor regulation. So yeah, here's our flywheel. First flywheel design just uses the flywheel with one motor and has a conveyor belt attached to the flywheel. Our second flywheel design. So